combine together. Generally, in general, we will say, okay. So in general, if I say that when non-metals and metal combine together, they form ionic compound. They are going to form ionic compound. And moreover, if I talk about then that when ions are the positive and negatively charged particles, okay. When an atom loses electron, it becomes positively charged ion. Like sodium lose one electron, it becomes sodium positive. And when an atom gains an electron, like Cl, when gain an electron, it becomes Cl minus. So it becomes negatively charged ion. So there are two kinds of ions. Okay. So when the positive and the negative charge ion are hold together with a strong electrostatic force, we say that they are the ionic compounds. Okay. So just a minute. Okay. So if I'm saying here, so what are ionic compounds? So ionic compounds are the compounds that are formed by strong hold of by the strong force of attraction between the metals and non-metal. Generally, why we are saying metals and non-metal? Because like you see that sodium is a metal and when chloride is a non-metal, when they combine together, they form uh, ionic compound. Okay. So here is the definition for the ionic compound. Okay. So please memorize this one. That first memorize this one. And then the ionic compound is a chemical compound composed of ions held together by strong electrostatic force. Okay. Here is a detail of ionic compounds. The first is formation of ionic compound. The ionic compounds are formed by the transfer of electrons by one atom and typically occurs between. Typically we are saying generally we can use word because in some cases like the ammonium chloride, if I'm talking ammonium chloride, NH4Cl, here are all non-metals. Here are all non-metals. But it is an ionic compound. Why? Because but here we see that ammonium ion is actually NH4 positive with positive valency 1 and Cl is -1. But the definition for this is that when the two elements with opposite charge are hold together by the strong electrostatic force, we say that, okay, that they are the ionic compounds. So ionic compound, we can say that in an ionic compound is a chemical compound composed of ions held together by strong electrostatic bonds or ionic bonds. And we can simply say that the ionic compounds are formed by the transfer of electrons. When one element is transferring the electron, it is permanently, okay, transfer means one is giving the electron permanently to the other element. Like for example, if I took sodium, okay, sodium, Na, and when sodium is having electronic configuration 281 and chlorine is going to have electronic configuration 287. You know that the nearest noble gas for sodium is neon, that is having electronic configuration 2,8, and argon is the nearest noble gas for chlorine, that is 288. So chlorine want to have the electronic configuration to that of argon, and sodium want to have the electronic configuration to that of neon. Means it wants to lose one electron and it wants to gain one electrons. So in order to attain the stable electronic configuration to the nearest noble gas, so what they will do, that Na is going to have 281 electronic configuration with one electron in its outermost shell, and here it is having 287 with 7 electron in its outermost shell. It will donate one of its electron to it permanently and will itself become Na positive, and it will become with 28 electronic configuration, it will become Cl minus with 8 electron in its outermost shell. Okay. Now they have given permanently. Now sodium is happy. Sodium is nothing to do with chlorine because it has given. Both have attained the stability. But they are hold together with a strong electrostatic force. One type of bond is bond which is formed by sharing of electron, in which the one atom is sharing the electron to the other one, another one is sharing the electron to the previous one. That is called covalent or sharing bond. But here, sodium has given its electron permanently to the chlorine, and chlorine has given its accepted the electron from sodium. They are happy. They are nothing to do with them, each other. They are good. Now, sodium can go anywhere. It is stable. Chloride ion can go anywhere. It is stable. But Why they are not going? Because they are strongly hold together with a strong electrostatic force. The ratio of the gravitational force to the electrostatic force is 10 raised to the power 39 times. Means electrostatic force is very huge force as compared to that of other forces that exist in the nature. So even though if sodium and chloride ions are having charges, they will be having opposite charges and they will be attract together with a strong electrostatic force of attraction, as a result of which they are tightly bonded and they form a crystal, a lattice, a crystal, a solid particles. So that's why ionic compounds are generally solid. Why? Because solid means the particle cannot move from one place to another place. Anything is solid means that the particle cannot move. So why the particle cannot move if they are tightly held together? So that's why sodium, the ionic compounds are generally solid in nature. Why? Because they are tightly hold together with a strong electrostatic force of attraction, which is very huge force. Okay, okay, understood. And the two types of question comes in examination, that why do ionic compound do not conduct electricity? Conduction of electricity means that the charged particle should move from one place to another place to conduct the electric current now. And if there is no movement of particles, the particle cannot move from one place to another place, then how can if the charged particle cannot move, then it means it is not going to conduct electricity in solid state. When we melt it, then the ions are free to move. They can move from one place to another place, or in the aqueous solution, they are dissociated. When you add sodium chloride to water, then they are dissociated. They are becoming Na positive and Cl minus. They can move from one place to another. When you add it to water, they are free to move. Okay, that's why we'll simply say that this Na positive and Cl minus in water can be result in the dissociation of ion. That's why the salty water is a good conductor of electricity. Salty water is a good conductor of electricity because they are having ions which are free to move now. But in solid state, they do not conduct electricity. So ionic compound conduct electricity in solid or in liquid or in molten state or in aqueous state, because ionic compounds, ions are tightly hold together with a strong electrostatic force. Understood? That's why they are not free to move. And if they are not free to move, they will not be able to conduct electricity. But in aqueous or in molten state, they are dissociated. Their ions are free to move. That's why they are conduct electricity. Okay? Understood? Second thing, if I'm having here is that why do ionic compounds have very high end melting and boiling points? The same reason. Boiling point is higher. Why? Melting point is higher. Why? Because melting means that the particle should move from one place. Melting means that something solid should go into the liquid state. If the particles are not held with very strong force of attraction, they can easily melt. But if the particles are held together with a strong electrostatic force, then we require a large amount of energy in the form of heat so that it can overcome that force of attraction and they are free to move. Any substance cannot be converted into liquid state unless and until its particles are free to move. And in ionic compound, the particles are only able to move when the force of attraction between them is overcome. And this force of attraction can be overcome only when they are held together with a strong force. Understood? When we provide high temperature. So here, first you have to memorize this one fast, and then you have to start writing this one in your copy. Noha and Nabi. Noha, turn on your camera. Done? Memorized? Gianna? Memorized?
Yes, sir.
And you, Noha? Are you there?
Yes, sir.
Okay, have you memorized this one?
1 minute, sir.
Start writing, please. Start writing.
Done, sir.
Done. Done this one? Yes or no? Done, everyone?
Yes, sir.
Okay. So just What are the properties of ionic compound? They have very high melting and boiling points. Okay, and if I talk about the properties of ionic compound, so why do they have high melting and boiling point? Because of melting point, because ionic compound is typically high, because and melting and boiling point because electrostatic force, because of the electrostatic force between the ions are very strong and require large amount of energy to break. So the question comes in, why do ionic compounds have high melting and boiling point? So this is the reason. So conduct electricity in solid state, because ionic compound do not conduct electricity. In solid state, ionic compound do not conduct electricity. However, when melted or dissolved, they conduct electricity because ions are free to move. Because okay, and most of the ionic compound, because they are positively charged and negatively charged particles, and water is also a polar substance. So ionic compounds are also polar. Okay, so ionic compounds are soluble in polar solvent. Polar means which have poles. Like water, we'll discuss the polar solvent. Like water, okay, which is having positive and negative terminals. Yeah, we can say that water when have combined together, it has positive and Cl minus ion. Sorry, positive H ions and OH minus ions. So they have positive and negative. They are called polar. So they are easily soluble. But like for example, if I'm saying CO, like if I'm saying glucose C6H12O6, like ethanol C2H5OH, so which are not polar, in these they are not soluble. Like petrol, they are not soluble in petrol. Any compound do not dissolve. If you want to dissolve salt in petrol, it will not be able to dissolve. Okay, because it is non-polar solvent. So ionic compounds are soluble in polar solvent like water, but insoluble in a non-polar solvent like oil. They don't dissolve in oil. The polarity of water molecules have to separate. Actually, this is the polarity of the water molecule. If I ask you that why, what is that thing in water that is helping to overcome this force of attraction, means if you add salt to the water, it can be separated. What is that thing? That is the polarity. That is the polarity. Like you see that if you have water molecule, so we have oxygen atoms and hydrogen atoms. Okay, so this oxygen will attract the bonded pair of electron because oxygen is very strongly electronegative element. What happened here is that some elements in the chemistry, they are very electronegative in nature. What does it mean? It means that when they are combining or making bond, they attract the bonded pair of electron towards itself. Like for example, nitrogen, oxygen, fluorine are the highly electronegative elements. So when they make bond with other elements, they attract the bonded pair of electron toward itself. Like for example, if hydrogen and hydrogen atoms are combining, so one hydrogen atom is here, one hydrogen atom is here, they are combining together, they will combine like this way. There is no bonding distortion in electron cloud base here. Or we can say that they both are of same power. But if hydrogen is making bond with fluorine, so what happened here is that this hydrogen atom and this fluorine atom, it should be like this. Okay, but actually when it is bonded, the electron of hydrogen is slightly shift towards the fluorine because fluorine is electronegative. So this electron from here, from this position slightly shift to this position. And because if the electron are shifted from some species, then it will become slightly negative and it becomes slightly positive. And because of the same phenomena, when oxygen in water is combined with hydrogen, so one oxygen atom here, one hydrogen atom here, one oxygen atom here, two electron here, one hydrogen electron here, okay, and the other two of oxygen. Total oxygen has electronic configuration 2,6. Only the outermost shell electrons 1, 2, 3, 4, 5, 6. Actually, this hydrogen electron and this hydrogen electron will shift slightly towards the oxygen. So as a result of which, the hydrogen have slightly negative charge, sorry, positive charge because its electron had shifted towards the, okay, slightly negative, and it has slightly positive, sorry, slightly positive, and it will have slightly negative. Why? Because its electron had shifted towards the oxygen. And this is due to the distortion or the difference in the electronegative power, in the difference in the attraction power of the two ions. So this is the way, this is the way the water is a polar compound because it has slightly positive and negative poles. And this negative charge slightly attract this sodium ion. towards, when you add sodium chloride to the water, then the crystal of sodium ion or the atoms of sodium ion will be attracted. This force will be reduced between these two forces. When someone is attracted towards this one, then this force will be reduced. So water, due to its polar nature, it attracts the sodium ions or the positively charged ion of the ionic compound towards itself, and the hydrogen of another, because it is having positive charge. So it will attract the chloride ion, Cl, Na. Okay, it will attract the chloride ion towards itself. So this is the way why the water, when you dissolve ionic compound in the water, okay, it is easily dissolvable, means it can be easily separated, and it can conduct electricity, and it can easily, means the high force between them is overcome, because water is attracting the sodium ion with the electrostatic force. This is also electrostatic force, negative and positive. It is electrostatic force. So when electrostatic force is applying on the other is electrostatic force, so it will cancel out each other. So this is the reason. That's why they are having. That's why when we add. Otherwise, sodium chloride, when you need to melt it, or if you want to separate Na positive and Cl minus ion, you have to provide approximately 2100 degrees Celsius temperature, which is very, very huge temperature. Okay, so it melt at very high temperature. But you add it on the in the cold water, even in the cold water, it can be easily separated, because here the oxygen atom, which is having slightly negative charge, is attracting the positively charged sodium, and another water molecules, hydrogen, is attracting the chloride ion. So that's why they are separated. So one oxygen atom, and this is the reason that this Cl minus ion gets separated. So same thing is being written here, that many ionic compounds are soluble in polar, and this type of compound that has polarity difference, this is called polar compound, because like, which is not the polar compound, which has the same power. Similarly, HCl is also polar, because I told you, oxygen, nitrogen, fluorine and chlorine, they are highly electronegative element. When they make bond with some other element, they attract their bonded pair of electron, unless they are bonded with the same kind atom, means Cl, they are of same power, they will not attract each other. H, F, they are non-polar. Okay, they are non-polar. F, they are non-polar. But when H and F, they are different. This H, the hydrogen, the chlorine atom will attract the hydrogen electron towards itself and will become slightly negative, and slightly positive. That's why it is also that HCl, when added to water, it can easily be separated out. Why? Because the oxygen of water is attracting the hydrogen of this one, and the hydrogen of another water molecule is attracting this chloride ion. So this is the reason that HCl, when you add acid to water, it dissociates the H plus ions. And water and acid, it is the H plus ions of acid which is responsible for the acidic character. That's why acid shows their property only in aqueous, in water, because H plus ions dissociation can only take place in water. Otherwise, if you have HCl alone, pure HCl, they are not going to separate. It will remain as it is. So these are called the polar compounds, which having poles. Poles means positive poles and negative poles. So slightly polar. This you are going to study in the higher classes in polarity in detail. The ionic compounds are soluble in polar solvent, like water, but insoluble in non-polar. Non-polar are those that do not have much electric difference, and they don't have poles on their different ions. The polarity of water molecule. This is the polarity. Polarity means positive terminals and negative terminals charge. Negative and slightly positive. This is the polarity. This is called polarity of water molecule that help us to separate the ion and dissolve the compound. If a water is not polar, or another substance which is not polar, in that substance, the NaCl cannot be dissolved, because it will not be separated. Okay. Ions, when get separated, they will become in their smaller size, then they can go into the intermolecular space. If you add a crystal of salt, it is bigger in size. Even you can see the crystal of salt with the naked eyes. But this crystal of sodium chloride is having billions of sodium ions and chloride ions. So these billions of chloride and sodium ion can be separated only when we add it into the polar solvent. Understood? Yes or no, everyone? And crystal
Yes.
is the structure of ionic means you cannot say that in a that ionic compound can make any structure. They are arranged in a specialized structure. Like you have chloride ion is bigger in size. Like this is Cl minus ion. Okay. So this Cl minus ion, like let me show you the crystal of sodium chloride. So this is the structure of sodium chloride. You can check it. Okay, this is structure of sodium chloride ion. This is structure of sodium chloride ion in which this chloride ion is this one. This green one is chloride ion and Na is positively charged. And they are arranged like this crystals. Okay. This is called crystal lattice. They cannot arrange themselves. This is the single part. Okay. They are arranged like this way. They cannot have any pattern. Okay. So they are arranged in a structure and they have fixed structure that is called crystal lattice. That is called crystal lattice. So crystal lattice means the structure of any compound from crystal lattice structure in solid state. This regular arrangement of ions result in well-defined geometrical shape and contributions of. So note each and everything of the ionic compound properties. Please fast. Done, everyone? Done. Noted fast. Done.
No,
Harshit,
sir.
Diana, and Noha. Noted.
Yes, sir.
You, Aisha, you noted.
Yes, sir.
Done? Maha?
Yes, sir.
Okay. Now, there is a structure called lattice structure. Okay. Sorry, Lewis dot structure. What is Lewis dot structure? Uh, it is simply representation of the how the chemical compounds are going to form. Okay, how the ionic compounds are going to form. Just a minute. So actually, if I talk about the Lewis dot structure, so in Lewis dot structure, what we study, only the valence shell electron we represent. First of all, like for example, if we need to draw that, how the sodium chloride structure is going to form. So sodium chloride structure, if I am talking about the sodium, only the valence electron, it is a rule of the Lewis dot structure that only the valence electrons are going to be represented. Sodium has electronic configuration 281. So it has one electron in its outermost shell, only this will be represented. You can represent it by cross or by dot, it's your choice. Okay, and it is 287. The outermost shell electrons of chlorine is 7. So we'll write only 7 electron, or we'll make only 7 cross. Now, this is the first step. Okay, the second step, in the second step, what we did, we represent the donation of electron, because sodium is going to donate 1 electrons to the chloride ion so that it becomes stable. So it will write, when it after a donation, it will become Na positive with electronic configuration 2, 8. And here we of metals, we don't represent the outermost shell electron, means the last 8 electron will not represent. Only the noble gas, sorry, only the non-metals electrons are represented after gaining the electron. It is having 7, but now when it gains, it is having 8 electrons, and now it will be acquire negative charge. And the third step, we'll write it like this way in the bracket Na positive, and here we will represent it Cl minus. Understood? Yes or no? Understood? So this is the representation of NaCl. So this is the Lewis dot structure. What we called it? This is the Lewis dot structure. So we can simply say that in the Lewis dot structure, means it is the generally foundation of the chemistry, that how the elements are going to bond. Why do NaCl has only the formula NaCl but not some other formula NaCl2 and something else? And why do magnesium chloride has MgCl2 formula but not other? So we say that Lewis dot structure is a foundation tool that provides a visual representation of bonding and arrangements of valence electron in a molecule. That how the arrangement, that how the valence electrons are arranged. By forming systematic step, chemists can predict the molecular structure according and understand the bonding patterns and the interference of the chemical behavior in different structures. Okay, in this one we only represent the outermost shells electrons. Like for example, if I'm talking about the MgCl2, why do MgCl2 has formula MgCl2, and why do magnesium has only MgO formula? Magnesium oxide has only MgO formula. The same reason, because magnesium wants to donate 2 electrons. 2 electron, it has outermost shell electron 2. And chloride ion can accept only 1 electron. It has a tendency to accept 1 electron. So someone wants to donate 2, and an element has it want to donate 2 to attain this stable electronic configuration. So what you will do, you will require two agents that can acquire one electron each. So 1 electron you will give it to this one, because sodium chloride ion can only accept 1. It cannot accept the 2. And here the magnesium, the another electron will be given to the another magnesium atom. This is the first step in which we will represent the outermost shell electron and the representation and the donation of electron arrow. The second step, after the donation, Mg will become 2 positive and the 2 Cl minus will acquire 2 negative charges, one negative charges each. And now they become Cl minus. And then after this one, what would happen? The third step, we will write it Mg 2 positive and then 2 in the bracket and then 2 Cl minus. We will represent only 1 Cl minus here, but we will write 2 here. Understood? Yes or no? And then same magnesium oxide is Mg2 positive. So Mg has two valencies and oxygen has 1, 2, 3, 4, 5, 6, 7. Okay, 6 electron. So since oxygen has 6 electrons, so it wants to acquire 2. So one oxygen atom is sufficient to accept. Harshit, and Harshit, why have you turned off your camera? And Gianna, you also?
Sir, my camera is on.
But you are not visible to me. It is showing black.
1 second, sir.
It's okay. Now, the first step, because magnesium can donate 2 and oxygen can accept maximum 2. So that's why one oxygen atom is sufficient for one oxygen atom. So that's why the formula is MgO. But here, one chloride ion will accept 1 electron. So that's why, and magnesium want to donate 2. So magnesium want to donate 2 and a chlorine can accept 1. So that's why we require 2 chlorine atoms. So that the donation of magnesium will be fulfilled. And here also, if this is the first step, second step is Mg, we will get 2 and then O, 1, 2, 3, 4, 5, 6. After gaining, it will become 8 and will become -2. And then the third step, we write Mg, 2 positive in the bracket and then O, 2, 3, 4, 5, 6, 7, 8 and then -2, 8. This is the way of MgO2 representation. Okay. So just a minute. Okay. So start writing. Start writing and drawing this structure, please. Without seeing, I'm just removing this one. Try to draw the structure of sodium chloride. First, you can check it. If you are having any issue, you can check it. But when I remove it, you have to draw it again, and then I will show you again if you have done some mistake. Okay. So draw the structure of MgCl2 and MgO. MgCl2 and MgO. Try to draw it. Done? Are you drawing? Gianna? Harshit and Noah?
Yes, sir.
Done?
Yes, sir.
Check whether if you have done some mistake. Check whether you have represented the non-metal's outermost shell's electron after a donation and before the donation. The electrons are represented here. And check whether you have, and it is MgCl2, you have written single and 2 here. Check the charge. You have written 1 charge for chlorine atoms or not. Let me check this one. Done?
Yes, sir.
Okay. Now the next one is Al2O3. One last, you have to draw the structure of Al2O3. How will you draw the structure of Al2O3? You will take 2 aluminium ion, 3 oxygen atoms. Try to draw the structure of Al2O3. Or you have to do this one in the homework, okay? Try to do this one in the homework. We will provide you the structure of Al2O3 and some other elements in the homework. And one more, aqua regia is there. Aqua regia is a mixture only, right? Aqua regia is royal water. Aqua regia, also called royal water. It is a mixture of concentrated HNO3 and concentrated HCl taken in ratio 1:3. When it is concentrated HCl first written and concentrated HNO3, concentrated HNO3 later, then you have to take the ratio 3:1. Okay, so sometime it is written like this way, sometime it is written like this way. You have to be sincere that here the HNO3 is 1 time and concentrated HCl is 3 times, and it is used to dissolve precious metals or noble metal. It is used to dissolve precious metal or noble metals like gold, platinum, etc. Put it down fast. Okay. So after doing this one, you can leave.